the oil protection medium slag, actually they when using the some flux, metallic oxide and other composition, and after welding the lighter weight slag is comes onto the upper side of the weld pool. So, slag this actually protect the molten pool in case of submerged arc welding and electro slag welding processes, and we can use both shielding gas as well as slag. Both this type of protection we can find out in the shielded metal arc welding process and flux core arc welding processes. And of course, we use the protection medium in vacuum in case of the electron beam welding process. So, when electron beam welding process has been done under the vacuum, so not necessary to use any kind of other shielding medium. So, that under the vacuum there is no chance of the reacting the surrounding atmosphere. So, electron beam welding process we can use the vacuum. So, that is the I think the most efficient protection medium in case of electron beam welding, that considers the under vacuum. Another case is the self protection, that in that case the self shielded arc welding processes we can use the self protection medium. So, that also comes the simply coating from the creation of the arc, and there may be some coating on the wear. But if you look into the laser welding also, sometimes laser welding we use the shielding gas also. Normally we use the argon shielding gas even in case of laser welding also. So, all type of welding processes to some extent we can use some protection medium. So, overall look into that gas stress arc welding we can use the either argon or helium, because using this under this shielding gas they can create the arc should be stable. So, argon and helium in case of gas will be the most suitable shielding gas, and because it produces the stable arc, and of course, the contaminated are with the less oxygen level, the contamination with the oxygen less using this type of the shielding gas. In case of gas metal arc welding process, we can use normally commercially we use the carbon dioxide, but difficulty of the carbon dioxide, that carbon dioxide can be decomposed into carbon monoxide and oxygen, and of course, finally it actually increases the oxygen level in the final weld joint because of the using carbon dioxide. Carbon dioxide is more commercially used, but we can use the inert type of gas also in case of gas metal arc welding process, but we need to know the stability of the arc under this shielding gas. And shielded metal arc welding, here normally you use the high oxygen level, and because shielded metal arc welding submerged arc welding process, we can mostly find out the high level of the oxygen, because of the we can use the silicon oxide also as a composition in the flux material. So, that is why oxygen level is high in case of the submerged arc welding process. So, apart from all this type of slag or flux or gas shielding gas, it is also possible to combine the different composition of the shielding gas. They may also affect not only the shielding purpose, they can affect the other aspects of the welding. Probably sometimes we use the mixing with the other shielding gas or type of the shielding gas, that mainly on the purpose of the stabilizing the arc, concentrating the arc, that is also, and sometimes we intentionally we use the other oxygen also, and that can be used as a surface active elements during the welding process. So, the purpose of the using shielding gas, not only the shielding of the molten weld pool, maybe to enhance the performance of the welding processes, sometimes best we can choose the composition of the shielding gas, or we can mix the two different types of the shielding gas, or we can mix the oxygen or with the shielding gas, so that with the specific purpose of the taking the effect of the surface active elements and to get some benefit in the surface using the oxygen in the with mixing with the shielding gas. So, if we look into that now gas metal reaction, little bit the chemical reaction in the welding process. So, first the reaction takes place between the gas, shielding gas and the liquid interface or liquid metal. So, the reaction happens between these two,
and during this reaction there is a dissolution of the oxygen, nitrogen and hydrogen in the liquid metal. But in basic way we will try to discuss that how this reaction happens. So, first we look into the reaction between the nitrogen and metal. So, how they react with respect to each other. So, when molten steel is actually exposed to the nitrogen, that results in the dissolution of the nitrogen atoms in the molten pool. So, weight percentage of the dissolved nitrogen at the given temperature can be represented by the Siebert's law. Here we can see that N equal to K into root over of P N2. So, here the K is the some constant parameter or constant term that is called the equilibrium constant term here. So, here you can see that this K can be linked with the other free energy of nitrogen in the liquid state, liquid iron, and that free energy of the nitrogen in the liquid iron can also be represented by this equation. You can see that it is some linear equation with respect to temperature. So, that also follows the Henry's law. So, here delta G actually represents the free energy of nitrogen in the liquid iron, and Pn2 is the basically partial pressure of nitrogen above the molten metal, and R is the characteristic gas constant. So, if we put the appropriate value here, and of course, all this reaction basically we see it is a, we are representing the reaction is as a function of temperature. So, therefore, having the reaction that happens during the molten pool with the atmosphere, that entirely strongly dependent on the temperature. Similar way we can find out the reaction between the oxygen and metal reaction. So, here we can find out that oxygen from atmosphere, and what may be the source of the oxygen. So, one source of the oxygen during the welding process, it comes from the atmosphere, and that may be due to the insufficient shielding process. Sometimes in oxyacetylene welding processes, the excess use of the oxygen in oxyacetylene processes, that can be a source of the oxygen. Sometimes we can use the oxygen that actually containing the inert shielding gas. So, sometimes the shielding gas may contain oxygen, either it is the inherent properties of the shielding gas, for example, CO2, or sometimes intentionally we can mix with oxygen with the shielding gas. For example, activated TIG welding process, we can use the oxygen with the shielding gas. So, that are the different source of the oxygen generally present in the shielding gas, and here when we use the CO2 as a shielding gas, and we can see the reaction happens at the very high temperature during the welding process. CO2 gas is decomposed into carbon monoxide gas plus half of CO, and if we look in the balance of the equation, and finally it can produce the carbon and oxygen. So, that carbon and oxygen can take part in the can be a part of the carbon, also react with the steel or using the base metal, and it may form the carbide, but oxygen can be a part of the oil metal molten oil pool. But here also the absorption of the oxygen also follows the Siebert's law, and we can see the similar way that free energy of oxygen absorption delta G, that is also a function of the linear function of the temperature. And here we can see the weight percentage of oxygen in the liquid iron can be found out by forming that, again it is a logarithm scale oxygen, and it is also a function of the temperature here also. So, overall that type of reaction, that type of equation can be Siebert's law may be useful here to roughly estimate the what is the amount of the oxygen can be dissolved in the molten pool, or it becomes a part of the welding system. So, overall if we look into that, what are the properties that actually impact in presence that with the presence of the oxygen and nitrogen content. Here the two graphs shows that nitrogen content, how the mechanical properties can vary, and with respect to the oxygen, how the mechanical properties vary, whether it can be used beneficially or not. Now, if we look into the first figure, the nitrogen content, here you can see
that nitrogen with the increment of the nitrogen content with the weld pool, molten metal of the or maybe the weld joint, we can see that there is a considerable decrement of the percentage of the elongation and impact load by increasing the nitrogen content. But in other way also we can find out that ultimate tensile strength and the yield strength that actually increases with increasing the nitrogen content. So, in that sense presence of nitrogen sometimes used the beneficially to increase the amount of the ultimate tensile strength of the joint, or maybe the we can if we try to improve the yield strength, then nitrogen is helpful in that sense. But of course, if you look into that oxygen content, here you can see that probably with increasing the oxygen content in the weld joint, that almost all types of the properties actually decreases. Here you can see the ultimate tensile strength, impact load, yield stress, elongation, all actually decreases in presence of the oxygen. So, that means we understand the mechanical properties at all not beneficial in presence or if oxygen content is high in this case. So, objective can be sometimes that to avoid the as minimum of oxygen content and maybe, but some moderate amount of the nitrogen, that actually helps to the improvement in the at least the weld joint strength in case of the fusion welding process. Now, we can look into the effect of the other components of the weld joint, that is the hydrogen, or how hydrogen and metal actually react, and we can see the first we look into that what are the source of the hydrogen in the welding processes. That first is the presence of hydrogen in stalls, that what is the consequence effect of the hydrogen. The presence of hydrogen in steel basically creates or susceptibility to the hydrogen cracking or cold cracking phenomena can be increased. So, therefore, it is beneficial to avoid the presence of the oxygen hydrogen in case of the weld joint. So, what are the source of the hydrogen here? The combustion products in oxy-fuel welding, the combustion product they may contain the hydrogen, moisture or grease sometimes used on the workpiece surface, or maybe we can find out the moisture in the electrode also, that can be act as a source of the hydrogen also, and hydrogen presence in the workpiece or hydrogen presence in the sealing gas. So, these are the typical source of the hydrogen in case of the welding process, but if you want to avoid these things, we can carefully measure this, that can be reduce the hydrogen level by simply avoiding the hydrogen containing sealing gas, that is a straightforward. Next is that if you the moisture may contain some hydrogen, moisture in presence of moisture is the source of the hydrogen also in the electrode. So, before using that we can dry the electrode and the flux, drying the flux to remove the moistures from that. In that way we can remove the hydrogen content in that type of the source during the welding process. And of course, cleaning the filler wire and the workpiece is necessary also to remove the grease, because that grease chemical, that grease is can be act as a source of the hydrogen also. So, therefore, cleaning is required for the workpiece surface. So, that is a safeguard to minimize or to reduce the amount of the source of the hydrogen normally in case of any case of welding system. But of course, presence of the some amount of the hydrogen that also follow during the welding process, simply the Siebert's law. Here we can find out that similar kind of equations here also. So, here we can that all the equations are also given, and here we can represent the free energy in this case, in this reaction also, that depends on the also the temperature and partial pressure of the hydrogen.